And I would like to call our next speaker, Dr. Marinella Striccoli from the same Institute for Physical and Chemical Processes of the Italian National Research Council. She's a physicist, specialist in colloidal nanocrystals and formation of composite systems from them. And today she will talk about colloidal nanoparticles in polymers.
Let me thank the organizing committee and Professor Chu in particular for his kind invitation. Here I will follow the presentation of Lucia, just showing you as these colloidal nanoparticles can be in some way used to produce innovative materials such as nanocomposite. So, indeed, the nanocomposite material are interesting because they combine the peculiar polymer properties with the size-dependent properties of nanocrystal in order to obtain new materials that with novel properties that can be in our, this is our goal, effectively engineered towards functional devices. The first one that I reported here is the in situ synthesis of nanocrystal inside the polymer. The second one, the second approach can be the polymerization of the organic matrix around the inorganic nanocrystals. And the third approach is the simpler one, is the ex situ incorporation of pre-made nanocrystals in polymer. In the following, I will give you some example of this last approach, that one that we follow in our lab. This is because the last approach allows us to preserve the properties and also because it allows us to preserve the polymer properties. And but the nanocomposite properties in general are depending from several parameters, such as the crystallinity, the molecular weight, but also on the kind of distribution of nanoparticle inside the polymer matrix, the nanocrystal surface chemistry, as Lucia told us before, and the nanocrystal composition. So this is the outline of my talk. I will show you some approaches for the functional nanocomposite based on these third strategies, so the ex situ pre-made nanocrystal incorporated in polymer. And then I will show you even some integration of such nanocomposite in structures and devices. So again, the main idea is to assess the nanoparticle properties by integrate them in devices. And this can be done, for example, by patterning technique that can, or by assembly technique that can allow the fabrication of controlled structures of nanoparticles. This can be done by following two approaches. One is the top-down approach, using patterning functional nanocomposite, for example, by ultraviolet lithography, nanoimprinting lithography, or inkjet printing, and so on. Or the second approach is the bottom-up by assembling nanoparticles, obtaining a quite higher control on and resolution. So, but amongst all the strategies for the fabrication of nanocomposite based on this ex situ incorporation, different approaches are available. The first one is, so when there are no specific interaction between nanocrystal and polymer matrix, and the nanocrystal are just mixed in the polymer with the use of a common solvent. A second, more refined approach is to choose ligands, nanocrystal ligands that are compatible, that show affinity with the polymer matrix. And the third one is to modify the polymer by introducing functional group that can be compatible with nanocrystal surface. And in the following, but also magnetic nanoparticle, iron oxide, gold, nanorod or nanodot, and also this emitting, well-known red emitting, in this case, quantum dot. So we start with the first approach, so no specific interaction between nanocrystal and polymer matrix. And in the next I will show you some example that of devices that have been even prepared in our structure and devices that have been prepared in our labs. The first simple example is here is polystyrene, a nanocomposite with polystyrene, and in which have been incorporated emitting quantum dot. Blue one has the cadmium sulfide, red. So the nanoparticles were loaded in the polymer, but in very low amount, so 3% and 5% is possible to obtain luminescent ink that can be used by inkjet printing that allow a local and precise deposition of material without any further processing step. And this allowed us, in collaboration with the BFL, Professor Jürgen Brugger of the BFL, to realize, for example, multicolor pixel array. But this kind of technique is very versatile. It can be applied to, for example, for produce ink of substrate, for example. Another approach is for this common solvent method is here, in this case, quantum dot red emitting. And so from the luminescence spectra, we can see that the nanocomposite, in this case, retain the emission properties of nanocrystal even after the sample, because the quantum dot came out from synthesis, as I said before, with this topo molecule that is insulating. And but when you need a charge transport, generally you use this kind of this ligand, as one of the ligand is used the pyridine. And here so the idea was to show how the pyridine with this multiple, this polymer with this multiple pyridine on the chain can modify the morphology of the nanocomposite. These are TEM image and IFM image of, in case of when nanocrystal are bare, means almost naked, without capping agent on the surface, we obtain aggregation. But these are nanocrystal with pyridine, so smaller aggregation, smaller in size aggregation, or in presence of topo that in a uniform distribution. The last example is this one. So we started a collaboration with a group in Bordeaux for the polymeric unique liquid, just adding a functional group, that is thiol group, that is also compatible with nanocrystal surface. And so the idea was to study possible charge transfer among nanocrystal and polymeric unique liquid. This was for different possible application of electronic field or in photovoltaic system, in a sensitized photovoltaic system in which this nanocrystal can work as sensitizer. And so to put nanocrystal in polymeric ionic liquid is because they are polar, we need to change the nanocrystal surface, and it was done by using these S2 minus ions that are very effective as a capping exchange. And so we prepared this nanocomposite that demonstrate that can be filmed and demonstrating a uniform homogeneous distribution of nanocrystals of quantum dot inside, but also the presence of possible charge transfer among the two moieties, as demonstrated by these time-resolved photoluminescence measurements. But so it is towards device fabrication, because the potential application are in several fields, such as photonic band gap materials, but also diffractive optical element, can I say, information storage devices and sensor and so on. And so I want to thank the project that allowed us to work in this year. And mainly our European project, but also national project. The collaboration of the several groups in Europe that allowed us to prepare device or test material in different conditions, and all our group, the nano group in Bari, and all of you for your attention. Thank you.
Thank you very much. Do you have questions?
Thank you, Professor. Actually, you have answered so many questions in my mind, to be honest. But one remaining question is, how about the stability under light? Because, you know, with these quantum dots, like if you use CDS at the beginning, so you might initiate photodegradation. So this is one thing. Second thing is that also I wish to see, maybe you said it but I couldn't get, was that with quantum dots of different materials you have different colors, you have different things. Did you refer to this in your work? Just like the Egyptians 4,000 years ago, you know,
yes, sure.
They did the same technology, and you are really going to technology. Thank you.
So yes, we know quite well that this decorated pottery, or this the glass just incorporating cadmium selenide or cadmium sulfide that change color with during the can you say, so the temperature treatment that move from yellow to red, just changing the temperature. You don't need luminescence. And then in that case, and also so the presence of a passivating external layer can be not good for charge transport. So in that case, you use just the core of cadmium selenide. Yeah. Is this the same for lead sulfide or other kind of materials?
One short last question.